Okay, good day everyone. Welcome to I Square Math Academy, where numbers meet mastery. In our last class, we actually found the derivative of three functions of x using the product rule. So in this class, I want us to compare that solution, yes, the solution we actually got using the logarithmic differentiation. Now, in this case, we have y is equal to x raised to the power of 3, e raised to the power of 2x times x. And here we are asked to get the value of the y all over the x. Now, solution using logarithmic differentiation. Logarithmic differentiation. Now, in this case, the first step is to take natural logarithm of both sides. Natural logarithm of both sides. Yes, natural logarithm of both sides. Now, it means here we have log y base e is equal to log to base e. Here we have x raised to the power of 3, e power 2x. Then here we have tan x. Yes. And now this is the same thing as saying log y base e is equal to log x raised to the power of 3 base e plus log e raised to the power of 2x base e plus log tan x base e. Yes, so what we actually did here, we actually used the law of logarithm, because in our when treating logarithm, we said when you have addition, you change the functions to multiplication. Okay, and when you have division, you change it to subtraction. So it means in this case, since we have x power 3 times e raised to the power of 2x times x, we actually change it to plus. So here we have log x raised to the power of 3 base e plus log e raised to the power of 2x base e plus log tan x base e. Now, differentiating both sides. Differentiating both sides. So it means here we have, when you differentiate log y base e, it gives you 1 all over y. Now, because this differentiation now is implicit, yes, because we are differentiating y and with respect to x, so we must follow it with the y all over the x. Yes, because we are differentiating with respect to x. Now it's equal to, when you differentiate 1 all over, when you differentiate x raised to the power of 3, ln x raised to the power of 3, it gives 1 all over x raised to the power of 3 times the derivative of this function, which is 3x squared. Yes, that's for this. Then plus the same thing, when you differentiate e raised to the power of 2x, it gives 1 all over e raised to the power of 2x times the derivative of this function, which is 2e raised to the power of 2x. That's for this. Then here we have plus. When you differentiate ln tan x, it gives 1 all over tan x times the derivative of the function tan x, which is sec square x. So it therefore means that 1 all over y, the y all over the x will be equal to, when you open this here, x squared will cancel this, you'll be left with x. So here we have 3 all over x plus, now this e raised to the power of 2x will cancel this e raised to the power of 2x. It means here we'll be left with 2, then plus, now let's look at this. Here we have sec square x all over tan x. Yes. Now it means here 1 all over y, the y all over the x, is equal to 3 all over x plus 2 plus sec square x all over tan x. Now let's multiply through. Let's multiply via by y. Yes, by this y. So it means here we have y in brackets, 1 all over y, the x will be equal to y in brackets. We have 3 all over x plus 2 plus sec square x all over tan x. Now, this y will cancel this y. I will be left with the y all over the x will be equal to, now this y, remember the value of y is this. Yes, the value of y is x raised to the power of 3, e raised to the power of 2x tan x. So it means now here we have x power 3, e power 2x tan x as the value of y. And here we have 3 all over x plus 2 plus sec square x all over tan x. Now looking at this, the y all over the x will be equal to, when you multiply this x here will cancel one of this x. So here you'll be left with x squared. So times 3, we have 3x squared, e raised to the power of 2x. Then here we have tan x. Plus, if you multiply this by 2, you have 2x raised to the power of 3, e raised to the power of 2x tan x. Now, let's look at this now. Sorry. This tan x will cancel this tan x. Sorry. We are multiplying it by 2. So here we have tan x. Sorry, please. So here we have plus. When you multiply the whole of this by this, so here we have this tan x will cancel this tan x. So we have x raised to the power of 3, e raised to the power of 2x. Then we have sec square x. So it therefore means that the y all over the x will be equal to, now let's look at this. X power 2 is common. E power 2x is common. So when you take out x raised to the power of 2, e power 2x, here you'll be left with this and this, they are outside. So here we have 3 tan x plus, this one is outside, and out of this x power 3, x squared is outside. We have 2x tan x, then plus. Now this one is outside, and out of this x squared is outside. So here we have x sec square x. X sec square x. So it means the y all over the x will be equal to e raised to the power of 2x, or you call it x squared before this. Then here we have x squared in brackets. So here we have 3 tan x plus, we have 2x tan x plus x sec square x. Now, if you look at this very solution using logarithmic differentiation and you compare it to this very one here, you will discover that it's the same value. So it means when you have more than 2 functions, you can either use the logarithmic function or you use the product rule when the functions are actually products. Okay, you can use either the logarithmic function or you use the product rule. So now this value here, the y dx is e power 2x. Look at it here, e power 2x. We have x squared, we have x squared, we have 3 tan x, we have 3 tan x plus 2x tan x plus 2x tan x plus x sec square x plus x sec square x. So thank you so much for listening to I Square Maths. In our next section, we are going to be looking at the quotient rule and how to apply the quotient rule in differentiating functions where you have division. Thank you for listening, and God bless you.